Next chapter, decimals. We have seen that fractions are part of a whole. A fraction whose denominator is a multiple of 10 is called a decimal fraction, or simply a decimal. For example, 3 over 10 is equal to 0.3. 11 over 100 is equal to 0.11. 135 over 1000 is equal to 0.135. And 15 over 10 is equal to 1.5. 3 things to note before we proceed. 1. In a fraction, the over sign simply means divide. So 3 over 10 means 3 divided by 10. 2. A whole number can be written as a decimal, having the decimal point placed at the right end, followed by a 0. For instance, 15 can be written as 15.0. And 3. When you divide a number by a multiple of 10, the decimal point moves to the left a number of steps equal to the number of zeros in the divisor. So if you have 123 over 100, 123 is the same as 123.0. 100 has 2 zeros, so the decimal will move 2 steps to the left. So we have 1.23. In a decimal number, the digits to the left of the decimal point represent whole numbers, and those to the right represent the fraction part. Place values. Consider the number 71,453.29806. For the whole number section, the place values are given just as we did previously. So we have ones, tens, hundreds, thousands, and 7 is 10,000s. As for the decimal part, we name them moving towards the right and not left. But the suffix s is replaced by th, and the first digit represents hundredth. There is no oneth. Next is thousandth, and then 10,000th, and so on. Next, converting fractions to decimals. To convert a fraction to a decimal, all you need to know is that the over sign means division. So you work the same division as we did previously. 2 over 5 means 2 divided by 5. So we have 2 and 5. 5 goes into 2 0 times. So we write 0 and a point. And then we add 0 to 2 to get 20. 5 goes into 20 4 times. And so 2 over 5 is the same as 0.4. 4 over 5, we have 4 divided by 5. 5 cannot divide into 4, so we write 0 point and add 0 to 4 to make it 40. And then 5 goes into 40 8 times, and that gives us 0.8. 5 over 8, we have 5 and 8. 8 goes into 5 0 times, and we put a decimal. We add 0 here. 8 will divide into 50 6 times. 6 times 8 is 48. We subtract and get 20. 8 goes into 22 times because of 16. We subtract, get 4, add another 0. 40. 8 goes into 40 5 times. And so 5 over 8 is equal to 0.625. If you follow the same process, 1 over 4 will give us 0.25. For fractions with denominators as multiples of 10, we simply move the decimal to the left. 9 over 10 is 0.9. 7 over 100 is 0.07. For mixed fractions, we can first make them improper fractions. For example, 2 and 3 over 4, we have 11 over 4, and then we divide normally. 4 goes into 11 2 times because of 8. We subtract and we get 3. At this point, we do not write remainder 3. No. We proceed, But because there is nothing to drop, we put a decimal point here and add 0 here. So we have 30. 4 goes into 30 7 times because of 28. We subtract and get 2. We add another 0, but we do not put a decimal. 4 goes into 20 5 times, and so we have 2.75. The thing is, during division to get decimal fractions, we do not write remainders, but the division has to proceed to the very end. Next, converting decimals to fractions. To convert a decimal into a fraction, we express it as a fraction with a whole number numerator and a denominator which is a multiple of 10, and then we simplify the fraction. For instance, 0.6. This has one decimal place, so we make the numerator 6 and a denominator 10. So we have 6 over 10. This simplifies to 3 over 5. 0.18 has 2 decimal places, so we have 18 over 100. Simplified, we have 9 over 50. 1.45, 2 decimal places. We have 145 over 100. Simplified is 29 over 20, as a mixed fraction is 1 and 9 over 20. 1.5 is the same as 15 over 10, which is equal to 3 over 2. As a mixed fraction, that's 1 and 1 over 2. Recurring decimals. Now convert 2 over 3 into a decimal. We have 2 divided by 3. 3 goes into 2 0 times, and we add 0 here to get 20. 3 goes into 26 times because of 18. We subtract and get 2. Add 0, it goes 6 times again because of 18. Subtract, we get 2. Add 0, and then it goes 6 times. This division will never end, and the 6 will keep recurring to infinity. This is called a recurring decimal. Others include 5 over 9, which is equal to 0.5555, 1 over 6, which is equal to 0.16666. Recurring decimals could also have more than one recurring digit. For example, 9 over 11. 9 over 11 is equal to 0.818181. 8 and 1 keep recurring. Because we cannot write the decimals to the end of the world, we simply put dots on the recurring digits. So 1.333 has only 3 recurring, and so we have this. 0.818181 has 8 and 1 recurring, so we have this. Sometimes we have 3 recurring digits like 0.1245, 245. 2, 4 and 5 are recurring. We place dots on 2 and 5 and we have this. Some fractions may be non-terminating but not recurring. For instance, 4 over 17 is equal to 0.235294, and the division will continue and never end. For such a case, we simply decide on the number of decimal places. The biggest headache is converting recurring decimals into fractions because they have endless number of decimal places. There is a special method to do this. For instance, 0.5 with 5 recurring. We use n to represent any decimal number, so n is equal to 0.555. We multiply both sides by 10 first, so 10n is equal to 5.555. If we subtract equation 1 from 2, we shall have 9n is equal to 5.0, and n is 5 over 9. Let's try 0.23 with 3 recurring. We start, n is equal to 0.233. 10n is equal to 2.333. At this point, you notice that the decimal parts of the two equations are not the same, and so we cannot subtract them. So we move on and multiply equation 1 by 100 instead. 100n is equal to 23.33. Now we can subtract equation 1 from equation 3. 100, and we shall have 90n is equal to 21. N is equal to 21 over 90. Simplified is 7 over 30. Finally, 0.468 with 468 recurring. N is equal to 0.468468. 10n is equal to 4.684684. 100n is equal to 46.8468. Still, the decimal parts cannot subtract. We proceed. 1000n is equal to 468.468468. So equation 4 can subtract equation 1. If we do that, 999n is equal to 468 and n is equal to 52 over 111. Next, rounding off decimals. In the same way whole numbers are rounded off to the nearest tens, hundreds, thousands and so forth, so are decimals rounded to the nearest tenth, hundredth, thousandth and so on. When a number is to be given correct to a specified number of decimal places, you look at the digit in the next decimal place, and if it's less than 5, you round down, and if it is 5 or more, you round up. For example, 3.4521 to 3 decimal places. The third decimal place is 2. Next to it is 1. So we round down and we have 3.452. Same number to 1 decimal place. First decimal place is 4. Next to it is 5. So we round up and we have 3.5. What about 5.698 to 2 decimal places? Decimal place number 2 is 9. Next to it is 8, so we round up. Adding 1 to 9 makes it 10, so we shall carry 1 to 6 to make it 7. Notice that we do not often write 0 after the last digit of the decimal. But when rounding off, it may be necessary to do so that we have the required number of decimal places. So we shall have 5.70. In the same way, 4.32 to 3 decimal places will be 4.320. Next, standard form. Standard forms are numbers written in the form a times 10 raised to power n, where a falls between 1 and 10, but 10 excluded, and n is an integer, meaning it can be negative, positive, or even 0. When a number is raised to power 0, it's equal to 1. So 10 raised to 0 is equal to 1. For example, look at 24. We can write it in standard form, so we can have 24 times 10 raised to power 0, which simply means 24 times 1. But then in standard form, the a must lie between 1 and 10. Remember, 24 is the same as 24.0. We can do that by moving the decimal point 1 step to the left, so we have 2.4. In standard form, when the decimal in a moves to the left, n increases by the number of steps moved. 24 becomes 2.4 times 10 raised to power 1. If we had 3,542, conventionally the decimal point is here. It thus moves 3 steps to the left, so we have 3.542 times 10 raised to power 3. What about 0.0245? In standard form, A has to be at least 1, so the decimal will move 2 points to the right. And so we shall have 2.45 times 10 raised to negative 2. This time n reduces because the decimal point moved to the right. Next, multiplying decimals. When multiplying decimals, we ignore the decimal points and multiply the numbers as if they were whole numbers. After getting the product, we insert the decimal point by counting from the right so that the number of decimal places in the product is equal to the sum of the decimal places in the numbers multiplied. For example, 2.36 times 0.7. Ignoring the decimal points, we have 236 times 7, that gives us 1,652. The total number of decimal places in the numbers together is 3, and therefore we need 3 decimal places in the product. And counting from the right, we shall have the decimal place between 6 and 1, so we have 1.652. 1.23 times 0.0064. Ignoring the decimals, we shall have 123 times 64, and that should give us 7,872. Count the total number of decimal places in 6 decimal places. And so we shall count from the right 6 places. So 1, 2, 3, 4. We add a 0 here to make 5, and another 0 to make 6 and the decimal place, and then we put a 0. So we shall have 0.007872. When decimals are multiplied by multiples of 10, the decimal point moves towards the right by equivalent steps to the zeros in the multiplier. For example, 0.2454 times 100. The decimal will move 2 steps to the right, and so we have 24.54. Finally, dividing decimals. When a number is divided by a multiple of 10, the decimal point moves leftwards, equivalent steps to the number of zeros in the divisor. For example, 245.329 divided by 100. The decimal moves 2 steps to the left, and so we have 2.45392. 21 divided by 1,000 will give us 0.021, and so on. Decimals are divided with whole numbers in the same way that whole numbers do. For example, 4.62 divided by 2, we shall have the same long division method. 2 goes into 4 2 times. Because of 4, we subtract and get 0. We put the decimal point and drop 6. 2 goes into 6 3 times. Because of 6, we subtract and get 0. We do not add another decimal, but we drop 2, and 2 goes into 2 1 time. So the answer is 2.31. 1.2 divided by 6, we use the same long method. 6 cannot divide into 1, so we write 0 point. and then we take it as 12, and 6 goes into 12 two times, and the answer is 0.2. In order to divide a decimal by a decimal, the divisor must first be changed to a whole number. We've already seen that multiplying decimals by multiples of 10 moves the decimal point to the right. Consider the operation 6.4 divided by 0.4. This can also be written as 6.4 over 0.4. We then find an equivalent fraction whose denominator is 4. This is obtained by multiplying the numerator and the denominator by 10 to make the denominator a whole number. And thus we shall have 6.4 times 10 over 0.4 times 10. That gives us 64 over 4, and the answer is 16. 6.36 divided by 0.3. This is equal to 6.36 over 0.3. We make the denominator whole by multiplying it by 10, but we also do the same with the numerator. So we have 6.36 times 10 over 0.3 times 10. That gives us 63.6 over 3, which is equal to 21.2. Finally, 0.1024 divided by 0.08. That is equal to 0.1024 over 0.08. We make the denominator whole by multiplying it by 100, but we also do the same with the numerator. 0.1024 times 100 over 0.08 times 100. That is equal to 10.24 over 8, and that gives us 1.28. Good luck with decimals.
It applies course to course, it applies class to class. Miss a class, one class, maybe that's fine. Miss 2 or 3 for whatever reason, the rest of they're speaking a foreign language for you, and you just have to make it up, or going to class has no point. If you don't go to class, it just gets worse. It snowballs, and once it starts going downhill, you're in trouble. And so the biggest secret, or the biggest piece of advice is get help early from as many people, and there's lots of sources for help, that other students in the course, teachers, etc. And so go there for it, and go early, and go as often as necessary.